Now, I've established the x and y conservation of momentum equations. Now, first of all, we know we can simplify these quite a bit, knowing that the mass is irrelevant because both pucks are of the same mass and they stick together at the end, which means we need not separate the final velocity of pucks 1 and 2 in either the x or y directions. So once this is simplified and we get rid of the m and the two velocity components on the right side of each of these equations, we get, in terms of x, the initial velocity of the first puck plus the initial velocity of the second puck, both in the x direction, is equivalent to the final velocity of the two pucks when they stick together in the x direction, as goes for the y direction as well. And the first puck is going to be traveling in the positive x and y directions at, as we established, at 2 meters per second. And that we can start substituting values to find the final velocity once the two pucks stick together. So the initial velocity in the x direction of puck 1 will be 2 meters per second times cosine of 45 degrees, because this puck, as we've established, is coming in at 45 degrees in respect to the other puck, plus the initial velocity of puck 2 in the x direction, which we know to be 0, equals 2 times the final velocity in the x direction. Now, we find this to be, canceling out the 2's first of all, simply cosine of 45 degrees equals final velocity in the x direction. Now that's going to be approximately 0.707 meters per second. Now we are going to do the exact same thing in the y direction. So 2 meters per second times sine of 45 degrees, again plus 0 because the second puck is stationary, equals 2 VYF. The 2's cancel out again, 0 is irrelevant, and we get that VYF, final velocity in the y direction, is sine of 45 degrees, which we also know to be approximately 0.707 meters per second. So the final velocity will simply be the square root of both of these values squared. So essentially just the square root of 0.707 squared times 2. So we find that to be 0.99995, or 1 meters per second.